Okay, so now let's talk about the Kubernetes API. And the core of Kubernetes control plane is the API server. And the API server exposes an HTTP API that lets end users, different parts of your cluster, and external components communicate with one another. The Kubernetes API lets you query and manipulate the state of API objects in Kubernetes. For example, pods, namespace, config maps, and events. Most operations can be performed through the kubectl command line interface or another command line tools such as kubeadm, which in turn use the API. However, you can also access the API directly using REST calls. Consider using one of the client libraries if you are writing an application using the Kubernetes API. So let's talk about the OpenAPI specification. Complete API details are documented using OpenAPI. The Kubernetes API server serves an OpenAPI spec via the /OpenAPI/v2 endpoint. You can request the response format using request header as follows. So you can see here an example of request headers and possible values and some notes about these values. If you want to take a look, you can pause the video and examine this. Okay, so Kubernetes implements an alternative protobuf-based serialization format that is primarily intended for intra-cluster communication. For more information about this format, see the Kubernetes protobuf serialization design proposal and the interface definition language (EDL) files for each schema located in the Go package that define the API objects. Persistency. Kubernetes stores the serialized state of objects by writing them into etcd, API groups, and versioning. To make it easy to eliminate fields or restructure resource representations, Kubernetes supports multiple API versions, each at a different API path, such as /API/v1 or /airbag.authorization.k8s.io.v1alpha1. Versioning is done at the API level rather than at the resource or field level to ensure that the API presents a clear, consistent view of the system resources and behavior, and to enable controlling access to the end-of-life and/or experimental APIs. To make it easy to involve and to extend its API, Kubernetes implements API groups that can be enabled or disabled. API resources are distinguished by their API group, resource type, namespace for namespaced resources, and name. The API server handles the conversion between API versions transparently. All the different versions are actually representations of the same persisted data. The API server may serve the same underlying data through multiple API versions. For example, suppose there are two API versions, v1 and v1 beta 1, for the same resource. If you originally created an object using the v1 beta 1 version of its API, you can later read, update, or delete that object using either the v1 beta 1 or the v1 API version. API changes. Any system that is successful needs to grow and change as a new use case emerges or existing ones change. Therefore, Kubernetes has designed the Kubernetes API to continuously change and grow. The Kubernetes project aims to not break compatibility with existing clients, and to maintain that compatibility for a length of time so that other projects have an opportunity to adapt. In general, new API resources and new resource fields can be added often and frequently. Elimination of resource or fields require following the API depreciation policy. Kubernetes makes a strong commitment to maintain compatibility for official Kubernetes API once they reach general availability, typically at API version v1. Additionally, Kubernetes keeps compatibility even for beta API versions wherever is feasible. If you adopt a beta API, you can continue to interact with your cluster using that API, even after the feature goes stable. Note: although Kubernetes also aims to maintain compatibility for alpha API versions, in some circumstances this is not possible. If you use any alpha API versions, check the release notes for Kubernetes when you upgrading your cluster, in case the API did change. Refer to the API versions reference for more details on the API version level definitions. API extension. The Kubernetes API can be extended in one of two ways: by custom resources that let you declaratively define how the API server should provide your chosen resource API, and you can also extend the Kubernetes API by implementing an aggregation layer. That's it for today. Thank you so much.